Good evening, everyone. I am Swagatika Devi, Assistant Professor, Department of Computer Science and Engineering. I am the coordinator of today's webinar, SOA CSE. This is the 37th webinar. I welcome you all to today's webinar, which is Cloud Computing Properties and Opportunities. Today's webinar is being delivered by Dr. Sampa Sahoo. Thank you, madam, for giving us your time. Let me now briefly introduce Dr. Sahoo. Dr. Sahoo has acquired her doctoral degree in Computer Science and Engineering from National Institute of Technology, Rourkela. She is currently working as Assistant Professor in Department of Computer Science and Engineering at C.V. Raman Global University, Bhubaneswar. Dr. Sahoo has not only qualified UGC NET and GATE like national level examinations, but has some very innovative research work published in IEEE Transactions on Services and Computing. Dr. Sahoo has authored and published many of her research findings in international journals and conferences. Her research interests are cloud computing, edge and fog computing, Internet of Things, and software-defined networks. Thank you, madam, for giving us your valuable time. Madam, I would request you to start the webinar. Over to you, madam. Sampa, madam.
Yes, thank you, madam, for the introduction. And now I will share my PPT. Is it visible?
Yes, madam. Clearly visible.
Okay, good afternoon, all. First of all, going to the detail of cloud computing, I want to know, have you heard of the statement like don't store the document in local storage, why not use the cloud? Have you heard of this type of statement?
Yes, yes, madam.
Okay, so what is a cloud? Why it is important? So actually, cloud is a cloud in cloud computing refers to the network or the internet. So here it is an internet-based computing where different services, including the server, storage, network, database, all the things will be delivered to the user through the internet. So basically, the servers or the all the physical requirements or components that is required that are stored in the data center, and from where the services are provided to the users through the internet. So why we need cloud computing? From the diagram, you can see that before the cloud computing, uh, the organization had I think server rooms where all the different type of servers like database server, email server, or um, any other servers will be there, and a lot of wiring is required, networking is required to maintain that servers. So what advantage the cloud computing will do here? That servers that are your database server or networking or any other servers that will be now being provided by a third party. So the organization or a particular company doesn't need to maintain this infrastructure. They can just rent this from the third party or the cloud service provider companies like Amazon, Azure, Google, and they can use that. So you can better understand this with an example like owning a house and renting a house. Earlier, the organization are owning all this infrastructure. So owning a house, if you compare, means all the functional for the functional requirements or the proper functioning of the house, all the things that are required that will be done by the owner. So it is a headache for the owner. and it will be time consuming. So how the renting a house will helpful, because the house will be provided by the that owner, and you can make changes according to your requirement while you rent a house. So like that, before cloud computing, all the uh, maintenance or all the hardware requirement, that will be done by that company or organization. But now that thing will be done by third party, so the time will be reduced, and effort will be reduced. User just need to rent or pay for the service from the cloud, and they can use that. So depending on this, these are the various benefits of your cloud computing, like reduced cost, and in cloud, it has a huge storage capacity. Then it is highly scalable, means depending on your requirement, you can either rent a lot of servers, or you can reduce the number of servers. It depends on your requirement. Then it will minimize the infrastructure risk. Since the infrastructure is maintained by the cloud service provider companies, so the company that is renting that services, they will have to less importance to maintain the infrastructure. More mobility means, since it is a internet based computing, so it can be accessed anywhere, anytime, and from any device. So more mobility is there. Flexibility, since you can change according to your requirement, so it is more flexible. So these are the few benefits of your cloud computing. Then what technology are there that are used to provide this cloud computing? So usually these four technologies are there: virtualization, service-oriented architecture, grid computing, utility computing. So what is virtualization? Actually, virtualization is a partitioning of single physical server into multiple logical servers. So in this case, a special software is used called as your virtual machine monitor or VMM or hypervisor, that will create a virtual instance of a physical component. So traditionally, you have hardware, computer hardware. Then on top of it, an operating system is there. After that, various applications are running. But after virtualization, what happens? That with the help of this VMM software or hypervisor, a virtual instance of the that hardware can be created. So here you can see that this is a single hardware components are there: RAM, hard disk, network card, or CPU. But due to this VMM, that special software, a virtual instance is created. So you can create as many number of virtual instance you want. So on that, this virtual instance is known as your virtual machine. Since physically they are not there, but they will act like a actual machine. So they are termed as your virtual machine. So here you can see that for this single physical hardware, two virtual instances are created. And on top of it, an operating system can be installed, and then various application can be run. For example, suppose you are using an Windows-based system. In your system, Windows operating system is there. But now you want to use the Linux operating system. So how you can use virtualization to get this task done? So what you can do, that you can use any VMM software like VMware and create a virtual machine. On virtual machine, you install the Linux operating system. Then on that Linux operating system, you can run any application. So at a single machine, now you can run both the operating system at the same time, like Windows base is your Windows operating system, or host operating system will be your Windows, whereas guest operating system will be Linux. So that is how the virtualization is helpful. So in cloud, this virtualization is an important concept. Due to this virtualization, cloud is so popular. Another technology that helps for cloud computing is your service-oriented architecture. Usually, service-oriented architecture, what it does, it will divide an application into separate functions or separate services, and each services will be provided accordingly. So this in cloud, we were often heard of saying like this is a cloud service. There is a particular cloud service for networking or entertainment services are there for storage. Amazon S3 is there, like that. So that is possible due to this service oriented architecture. Another technology that is being used is your grid computing. So what the grid computing does, it is a type of your distributed computing where a group of computer resources from various locations are connected to each other to obtain a common objective. So similarly, in cloud, a lot of resources will be there, and that resources will be used by various applications or companies that can have a common objective. Next technology that is being used is your utility computing. This computing can be better understood with an example of like electricity bill. At the end of the month or the bill generation time or date, the how the electricity bill is generated, it depends on the number of units that is being consumed at that particular month. Based on that, at the end of the month, you will get an electricity bill. Like that, in cloud, what happens, depending on your use, you will pay the amount. So from utility computing, the cloud computing takes this pay per use uh, model or technique. So in like your utility computing, where the computational resources are provided in method based services, like that in cloud computing, all the services are provided pay per use model, based on pay per use model. So what advantage it will give? It will reduce the IT cost, it provide the greater flexibility, and it is easy to manage. So if you consider the cloud computing, then key takeaways on cloud computing are your what are the essential characteristics of cloud? What is delivery model? What are the deployment models? So there are five characteristics basically. Three delivery models are there, four deployment models are there. So collectively, these are also known as your 3, 4, 5 model. Three delivery model, four deployment model, and five essential characteristics. So these are the five characteristics of cloud computing. First is on-demand service. Means whenever you need, you can just ask the provider, service provider, that you want this service. Then on demand, within few minutes or within a short time, you will get all the service from the that service provider. Then another one is your broad network access. Broad network access means you can access the service, cloud service on heterogeneous devices, heterogeneous networks. Heterogeneous devices means you can access the same service in your mobile as well as laptop as well as tablet, whether you are using Wi-Fi network or Dell network, uh, you can access the services. So that broad network access tells that anywhere, anytime, the cloud service is available. The next is resource pooling. So resource pooling means what all the computing resources uh, or the cloud resources like your computing servers or network servers, database servers, all are present at a single place, and many company use these resources simultaneously. For example, like you must have heard of the term carpooling. So what happens in carpooling? A single car is being used by multiple person. Similarly, here all the cloud resources are present at a single place, and it is being used by multiple companies or organizations. So that is what resource pooling is. Next is rapid elasticity. Rapid elasticity, it means depending on your requirement, you can uh, change the number of cloud resources you need. Means currently suppose you have an application to run that you need two computing resources or two computing servers. So it currently you have two computing servers. Now after some time you feel that you need two more computing servers. Means all total you need four computing server to run that application in a better way. So what you will do, you can ask the service provider to increase the number of computing resources on your account. It will be done within few minutes, and now you will have all the four resources. How it is advantageous? Uh, Consider before the cloud. So earlier you have two servers, now you require two more servers. So what you will have to do, you have to bought this two servers, ask the expert to configure that, maintain the network architectures. So it will take time as well as the cost and effort. So that is now reduced with the help of cloud. Depending on your requirement, you can either increase the number of resource or you can decrease also the number of resource. So that is what rapid elasticity is there. Then measured service means,
Madam, the
as I
slides,
said,
sorry, ma'am, but the slides are not moving.
but I am in this slide only.
Okay, ma'am.
Okay, measured service means the whatever service are being provided that are uh, you will be charged based on the time you have used that particular service. Means usually the cloud services are provided based on number of hours, or if you go on higher side then number of months or years, you can rent or subscribe to that particular cloud service, and depending on that you will be charged. So next comes the delivery model. So how the cloud services will be delivered to the user, that covers your delivery model. Basically, there are three types: infrastructure as a service, platform as a service, software as a service. So in case of infrastructure as a service, the all the infrastructure that is required to run a particular application, that will be provided by the cloud service provider. Now its user task is to install all the software required and how to manage that. All the things will be done by the user. Whereas in platform as a service, Whereas in platform as a service, what happens? The infrastructure will be there, but the application that needs to be run there or the data that will be managed by the user. But in software as a service, what happens? All the things will be provided by the cloud service provider. User only has to use that particular software. So for explaining that, this example can be better used. Pizza is a service. So traditionally what happens, if you want to eat the pizza, then you have to make that pizza at home. You will have to use all the resources like pizza dough, all the sauce or oven, dining table, all the things you will have to provide, or it should be available at the home. But if you consider these three type of services, then how they are different. In case of infrastructure as a service, the service provider uh, will provide you the pizza dough, sauce, toppings. You have to take that content and bake it, then use your table, your utensils to eat that. So that this infrastructure as a service is like take and bake. Similarly, platform as a service, if you consider, then pizza is delivered, means the service provider or the pizza company will deliver you the pizza. Only you have to use your table, and if you want soda, then you can take soda and eat it. That is your pizza delivered, and that is like your platform as a service. But in case of your software as a service, like dined out, means you have gone to the pizza company and you eat there, order their pizza and eat there. So that is your software as a service. In software as a service, you don't have to make any extra effort. You just need to use the whatever services, whatever available. So if you compare, then IS example is your Rackspace, Equally Purchase, Amazon EC2. PaaS example will be Google App Engine, and SaaS example can be your Gmail, Facebook, like that. So next come to the deployment model. So deployment model means how the cloud servers or the infrastructure will be deployed for running of a particular application. So there are four types of cloud deployment models. One is private cloud, another one is public cloud, hybrid cloud, community cloud. So as the term private is there, means private cloud, if it is being designed or it is being used, then it will be dedicated to a particular company. For example, here company A wants to use the cloud service. Then the cloud is specifically designed, the cloud service is specifically designed for that company only. Then it is called as your private cloud. So there are two types of private cloud. One is your internal private cloud, another one is your hosted private cloud. So internal private cloud means within, if a company A wants the cloud service, then within that company's surrounding or premises, the cloud setup will be there. But in case of hosted private cloud, if company A is there, then suppose company A is in city A, then the cloud setup can be done at its another office that is at city B. So that will be your hosted private cloud, means third party will be involved to set up the uh, to store or the make the cloud setup for that company A. Next comes the public cloud. So in public cloud uh, or the external cloud, where the infrastructure facility are provided by the third party. So in public cloud, what happens? Multiple companies can use the same cloud. Gmail uses the public cloud. Okay. Next come the hybrid. So hybrid means, as you know, hybrid means it must be mixture of one or two different type of things. So in case of hybrid cloud, it is a mixture of your two or more types of cloud environment. It can be a combination of public cloud, private cloud, or even here the traditional infrastructure can also be included. So that will make the hybrid cloud. Related to hybrid cloud, one more term is there, that is your multi-cloud. So in case of your multi-cloud, uh, multiple public clouds are used. But in case of your hybrid, one private cloud must be there. So if only the public clouds are combined, then that is termed as your multi-cloud. For example, hybrid cloud, you can say that it is a combination of apple and orange, but multi-cloud will be the different type of apples. So another deployment model is your community cloud or cooperative cloud. Usually community cloud is designed for a particular community that have same work, or they have same interests like that. For example, Facebook community. So for Facebook community, a cloud server or cloud setup can be done. Okay. Then till now we have talked about all the advantages of cloud, but even nothing is perfect. So even if it is perfect, then there are chances of some improvement. Like that, cloud computing has many advantages, but it has some challenges also. So what are the different challenges? You can say security and privacy is there. Means in cloud, what happens? You are transferring your personal documents to the third party. So if they will misuse it, then it will be a great concern. So security and privacy is a challenge in a cloud infrastructure. Then there is reliability and availability. So availability means the downtime should be less. Then there is power management. The infrastructure that is required to proper functioning of the cloud service. So for that infrastructure, power will be used. So how to make that energy efficient or power efficient? That is another challenge. Then service quality should be high. Then portability, as I said, cloud means you can access the service anytime, anywhere, any device. So how to make the service portable? That is also a challenge. Interoperability comes when there is multiple cloud. Means suppose a company wants a particular service from Amazon, that is one of the cloud service provider, then and it wants another service from Google, that is also a cloud service provider. Then how that Google cloud service and Amazon works, Amazon cloud service will integrate with each other, or whether they will that service A and service B will work with each other or not, that is your interoperability. How the services of different cloud service providers can work with each other to fulfill a common task. So what Out of these challenges, I am discussing the power management here. So power management, as I said, power management means the infrastructure that is used to or used for the proper functioning of the cloud service. They needs the power, and the power cost or the whatever power that is required, that should be minimized. Otherwise, because the power high consumption of power will have negative effect on the environment, so that should be reduced. So researchers have worked on these challenges a lot, where they have proposed various techniques to make the system, cloud service systems or cloud systems more power efficient. So out of various techniques, one technique is VM consolidation. What is VM consolidation? Here you can see that before VM consolidation, the VMs are scattered in multiple physical machines. So for example, let's say here three servers are there. Server 1, server 2, server 3 are there. In server 1, two virtual machines are there. Server 2, one virtual machine is there, but in server 3, one virtual machine is there. So server 2 and server 3 run only one virtual machine. So if you switch off these servers and transfer the virtual machine 3 and 4 to that server 1, then it will be benefit and it can be help to reduce the power. Since server 2 and 3 will be off, so they will the power consumption will be reduced. So this scenario is before VM consolidation. Now after VM consolidation, that VM 3 and 4 are placed at server 1. So since server 2 and server 3 are empty, they doesn't have virtual machine, so they can be switched off. So in this way, power can be saved. So to transfer this VM3 and VM4 to server 1, actually VM migration is used. That is also a part of your VM consolidation. So this is your one of the power management technique. Another way by which you can reduce the power consumption is task scheduling. Task scheduling means whatever task or application that needs to be run in the virtual machines, they should be distributed or distributed in such a manner that they will use the less number of virtual machine, and so that the power can be reduced. So basically, scheduling algorithms are designed so that the tasks that are coming to the cloud or the incoming task of the cloud, they will be scheduled to a virtual machines, so that the power consumption will be reduced. So if you consider the scheduling algorithm, they can be of different types depending on for what purpose you are designing the algorithm. For example, if you are considering the architecture, then you can design a centralized or decentralized type scheduling algorithm. Then the scheduling techniques can be your heuristic based, meta heuristic based, reinforcement learning based, game theory based. If you consider the performance metric for task scheduling, then it can be energy aware. Energy aware means here main focus of this scheduling algorithm is to reduce the energy. Similarly, cost aware means the main focus of the algorithm will to reduce the overall cost. Then can be your fault tolerance aware, then reliability aware or max span aware. Depending on performance, this type of scheduling algorithm can be designed. And if you consider the objective, then it can be single objective or multiple objective. Single objective means you are designing the algorithm for suppose only for reducing the energy consumption. Multi-objective means more than one objective is there for that scheduling algorithm. For example, suppose you want to reduce the energy as well as the cost, then that will be your multi-objective scheduling algorithm. Then if you consider the mode of operation, get me your batch mode or immediate mode. In batch mode, what happens? A group of tasks will be scheduled to the VMs. Each time out of that incoming request, different groups will be there or batch will be there, and one by one batch will be assigned to the virtual machines. Whereas in immediate mode, as long as the request is there to the cloud service provider, immediately the task will be assigned to the virtual machine for execution. So if you consider the future of the cloud computing, so it has a bright future. So nowadays, instead of cloud computing, edge computing and fog computing are mostly considered. Reason is that compared to cloud computing, edge computing or fog computing, the servers are near to the data source. In cloud computing, what happens? The servers are at remote places, so the service delay or the delay to give a particular response, there will be delay for a particular response. So that's why an advanced version of cloud computing is designed, that is your edge or fog computing, where the computing resources are usually placed near to the data source. And this edge and fog computing also are useful for this Internet of Things. Nowadays, we must have heard of this term Internet of Things or sensor-based applications, smart application or smart city applications. So what it is, various smart city application like smart home, smart building, smart transportation, smart healthcare is there. So first, the computation, if any computation needs to be done, that will be sent to the edge or fog layer. After that, it will be, if this edge or fog layer is not sufficient to process that task, then they will be sent to the cloud layer. Use of edge computing and fog computing doesn't mean that cloud computing is not there. Only thing is that for to reduce the delay, the in between cloud and this smart applications or IoT application, a middle layer is designed, that is either edge or fog layer, that will give the quick response. But for task that requires a large processing or large storage space, that will now also will be sent to the cloud for computation. Similarly, nowadays cloud is being designed for performing specific tasks, like if it is used for data analytics, then that cloud is termed as analytic cloud. If you have designed the cloud infrastructure for the database, then it can be your database cloud, like that. So with this, I'm concluding my presentation. I would like to thank ITR authority to giving me this opportunity. Thank you.
So, any questions from any attendees can be entertained. Madam Dr. Madhuri Rao has a question, madam, that is in the chat box. So, madam is asking about some project related cloud computing paradigm and what simulation can be used. So, can you kindly explain on that?
Projects, if you consider the challenges of the cloud computing, then you can consider the problem statement related to this challenge. Like what I have discussed about power management. So you can take this as a problem, how to reduce the power consumption or energy consumption in the cloud system. So it can be a good project, or you can, if you are more interested in the hardware thing or networking thing, then you can go for the networking infrastructure of the cloud, and there you can design the networks or the overall network which can be used to deliver the cloud service in as early as possible, or that can be used to reduce the time, service delivery time. Like that, you can also go for the reliability and availability. Security is also there. So you
Ma'am.
can take any of these challenges as your problem statement, and you can propose the solution for that. And about the simulation, you can use cloud for your simulation work. Otherwise, you can develop your own simulator, or you can write your own code to simulate whatever you want to do in to solve your problem.
Okay, madam. Thank you. Any other questions from any attendees? Okay, I would now request Dr. Madhuri Rao to give vote of thanks. Madhuri, madam?
Yes, ma'am. Thank you, ma'am. Ma'am, can we
Okay.
have a picture? Like, can we have a video on, Sampa, ma'am? Just for
Yes,
the
yes.
picture.
Madam, please.
Swagatika, ma'am.
Yes, madam.
Swagatika, ma'am. And ma'am, thank you. And on behalf of the Department of Computer Science, SOA University, I would like to thank Dr. Sampa Sahu for giving her valuable time and explaining us about cloud. I would also like to thank our coordinator, Swagatika ma'am, for arranging this session. We must thank our convener, Dr. our HOD, Professor Debavati Mishra, ma'am, our assistant HOD, Dr. Sarda Prasannapati, Bharat sir, and Dibya Sundar Das sir for giving and making this event possible. I would also like to thank all the participants to be able to join and to take benefit from the program. So with this, ma'am, thank you so much.
Thank you, ma'am.
And we hope to get in touch with you in future if our students have any doubts and if they if we can connect with you. We definitely look forward to that, ma'am. Thank you, ma'am.
Yeah. Thank you.